Okay, so let's start looking at, we are now in week 5. So we have already covered 4 weeks worth of material. So we are now going into the second half of this course. If you have, as I mentioned to you very early in the course, that this is an 8-week course. So we are in the 5th week now. So in the 5th week, we will start looking into where we have left at the end of 4th week, which was we were looking at this ISO methodology and different components of how to do LCA. So let's look at kind of continue that. I started, if you remember from the last video that we had, we were looking at unit processes. So let's continue looking at from the unit processes side, and then we'll look at the other aspects in terms of the LCI database, impact assessment, and all that. So in this particular module, we'll start looking at the unit process and data and LCI database. So this was the last slide you saw towards the end of last module, where we looked at the unit. If you remember, we talked about this particular box which we were trying to cover, that you can have 2 types of unit processes. There could be one unit process which is an intermediary flow, 2 types of flow, not unit process actually. There is a 2 type of flow between the unit processes. So what is unit process? It's a subdivision of the product system assuring a unique or a group of activity or operation. So it's a product, we have a product system, it's a subdivision of that, and it gives us a unique or a group of activity happening there. There could be 2 types of flows, we looked into that. When we say flows, it is the input and output of the system. One we defined as intermediary flow, which is where the 2 unit processes are linked. Linking 2 unit process, one or more represents the function of the unit process, and that then could be elementary flow. Elementary flow is where the unit process is linked with the environment. So the top one here, the unit process 1, has an elementary flow coming to unit process 1, elementary flow going out of unit process 1, and then unit process 1 and 2 is connected through the intermediary flow, linking the unit process 1 and unit process 2. So this is how it has been defined. This was the last slide we looked at towards the end of last week material. So in theory, so there will be a lot of processes which will happen to achieve the function that we want to achieve. So as you can see, this is again the box came very similarly to what we had earlier. We looked at in that our bulb exercise as well. So for any of these life cycle analysis activity that we do, we have resource acquisition, where things has to be acquired, where your mining activities, then manufacturing, distribution, use, and end of life. So this box kind of signifies cradle to grave. And for this box, if you look at any product, this whole thing needs to happen for in terms of the product's life cycle, and that product is giving us a function, and we will use a functional unit to quantify all these inputs and outputs. So the inputs, again, natural resource, extraction, iron ore, crude oil, water, wood, solar energy. So these are our inputs. Outputs were emissions, air emissions, water emissions, soil emissions, and also other environmental interventions in terms of radiation, heat, noise. So these are all outputs associated with that. So in theory, we have all process we require to fulfill the function. We will take all the process which we require in terms of getting into the function of that particular product, and they include pretty much from cradle to grave. If we take the cradle to grave concept, it includes from resource acquisition all the way to end of life. So that's our complete life cycle. The previous box that you saw was a complete life cycle. But as I said earlier, many times you may not do complete life cycle. If you remember, I talked about that. Say if you're running a company and you make a product, then after the product leaves the boundary of your company, then you can make an argument that I don't have any control on that product anymore. So I don't really, what happens to the product once it leaves my gate, I don't know. It's because it depends on what kind of users I have. Some users may be environmental friendly, they will take more care in terms of using the product. Others may not care that much about environment, and they may not take care of, so they may use it in a way which has bigger environmental footprint. So we have to, that part is, as a company, I have like a no control over that. So one can make an argument, and that's a very valid argument. So in those kind of scenarios where you don't really go all the way to the end, if you are doing only resource acquisition, if you look at this box again, if you're just only doing resource acquisition, manufacturing, distribution, no use and end of life phase. So that's where we are just from the cradle. So this is to the gate. So as you can see here, we are not taking the use phase and the end of life phase. So that's, there is no disposal or no recycling, composting, waste to energy, those things are not coming in here. So here the product being unchanged. So LCA here, different manufacturing process for the same product. The product being unchanged, the use and end of life stages are the same and can be excluded. So if it's a use and end of life can be excluded, then it becomes a cradle to gate study. So that's where you are only going from the cradle to the gate, and you are not looking at the use phase or the disposal phase. If you look at some product, especially where the disposal or the use phase is one of the dominating phase in terms of the environmental footprint, many product may come out to be much nicer. When I say nicer, means from the environmental point of view. From an environmental point of view, they come out to be very good if we do a cradle to gate study, if we exclude the end of life or the use phase. For example, anything containing heavy metals, say for example, if there is something containing lead or mercury, we had electronics and all that. So when these heavy metals, its a disposal part becomes very critical. Say if the things ends up in the landfill or in a dump, like in India, still we are way behind in the waste management system. We need to make a lot of improvement there. With the new push with the Swachh Bharat mission and all that, hopefully we'll make progress in that area. But still we have to make a lot of progress. And so that's, say right now most of the waste material in India is it's not managed. There are some good things happening in the country. So I'm a very optimistic person. So there are some really good things happening in the country in the waste management sector as well. Those things needs to be kind of we need to learn from those and kind of replicate similar stuff elsewhere in the country. But majority of places in the country, majority of big cities or small cities and towns, they are struggling with waste management system. So anything with like a high heavy metal or like a lot of, when I say high, it's a higher concentration of heavy metal, or things which has a potential to pollute the environment during the disposal in a big way. If you exclude the disposal phase in your life cycle analysis, as in this particular example over here, if we exclude this end of life, they may come out to be much nicer. They will show up to be, it's a very nice like a result, which may not be really true. Some of like mercury lamps or lead containing electronics, those will be the cases where their environmental footprint will come out to be much better if we exclude the disposal phase. So we need to be careful with that. So that's why whenever you look at as I said, if you are a young professional right now or a young student right now who will be working in this field, in the environmental field for say next 30, 40 years as a career, or say if it doesn't matter which area you will work, because these days this environmental impact is it needs to be looked at in every aspect. Even if you are working for in a company as a manager, say after you become an engineer or whatever, and then you do an MBA degree and then you become a manager for a company, is still there also you have to, things are so much interrelated now. You will either you have to look at some of these environmental footprint data or report. So you have to make sense of the report, what these reports are. Either you will be, if you are a hardcore environmental professional, you will be producing this report. If you are working on the other side as a manager or even for a regulator or like an environmental regulator, a state pollution control board, central pollution control board, and all those different positions that you can end up, or in the MOEF for example. So there you will be looking at these reports. So when you look at this report, you should be able to understand that report. So when you look at this LCA report, as I may have said earlier too, you should look at the system boundary very carefully, whether it was a cradle to grave study or cradle to gate study. Something may look very good in cradle to gate, but when you do a cradle to grave study, it may not look as good because of the impact that it will have, especially during its disposal phase in a waste to energy plant or in a landfill and those scenarios. So that's like a cradle to gate concept. We kind of talked about that a little bit earlier, but here it's a good and then it's a good like a example that we had to look at that as well. Then you may have something which is only when you look at only on the municipal, say if you only look at the end of life. So, if you want to do a life cycle analysis only on the municipal waste management, so if you are looking at the municipal waste management, we just talked about like a Swachh Bharat mission and the municipal solid waste. Say for we are like I am sitting here in Kharagpur. So Kharagpur is a town in West Bengal with it's a decent sized town. Now for example in the town of Kharagpur, they want to have a municipal solid waste management system. So when they want to have a municipal solid waste management system, they can have different options to go for. They can go for a compost plant, they can go for a waste to energy plant, they can go for a landfill. I am talking about engineered landfill, maybe anaerobic digestion for the food waste. So there are different options out there. So for all these different options, of course, which options to choose will depends on what is the waste composition, how much is the calorific value, how much is the biodegradable fraction and all that, and will not go into that particular aspect. That will be a separate course on municipal solid waste management, which probably will be offered later later as well, but not in this particular course. So we have in terms of like if you are just focused on the end of life, whether composting, say there are different options. I was giving you the example that in outskirts of Toronto there are 3 small towns, small from the Indian context, pretty big from the Canadian context, because anything with 600,000 population is considered very big over there. So this Mississauga, Brampton, and there is another Caledon. These 3 together is called Peel region. So we did a study, like when I say we did a study, like myself and my students, we worked on a study for that Peel region where they had the different options, where like anaerobic digestion, landfill, like a bioreactor landfill or a non-bioreactor landfill, and then they are sending it to whatever is residual. It's like that's a landfill. There is no residual here, and then you have a waste to energy plant, like a compost, waste to energy plant, and residual from both compost and waste to energy plant going to a landfill. So there was 3 or 4, like 4 different options we had come up with, and then for these 4 different options we did a life cycle analysis and to see which option comes out to be better. So for all that, we are not worried about resource acquisition, manufacturing, distribution, or use phase, because this is common. This waste material, the waste material that is coming in, it doesn't matter which like it's the same thing. It's the waste material is coming because we are focusing only on end of life. We are looking at the end of life options. We are looking at the waste disposal options. So once the product is made waste, it's already the earlier part, whether we go for composting, anaerobic digestion or landfill, the previous impact remains constant. So when it was restored, when it was made in a manufacturing plant, when it got sold, when people used it, that particular aspect, those things is the same. So since it is same, we can ignore that part, because the environmental impact associated with those aspects will be there, whether we go for compost or anaerobic digestion or landfill or waste to energy plant. It will be the same environmental impact. So it's like saying that you have equation where you have a plus b plus c on one side, and the other side you have a plus b plus d. So since a and b is common, you can get rid of a and b and we just look at c and d. So that's similarly over here, we can get rid of those factors which is common for, especially when you are doing the comparative LCA. So for end of life, here where the stages before the end of life are the same, so we can exclude that. That's what we are talking about here, and that becomes gate to grave study. So here we are just looking at gate to grave. So there are different types of studies you can do. There are softwares which actually specializes on working only for municipal solid waste management life cycle analysis. There is a the software name is eStake. I think earlier it was EaseWaste, now it is called eStake, or maybe vice versa. Earlier it was EaseWaste, now it is called eStake. But this software is developed by Technical University of Denmark, and they give this software free of cost to academic people. And only thing is that you need to go and take a 2 weeks training in Denmark, in Copenhagen, in outskirts of Copenhagen, and they will give you software at the end of the course. But they want you to use the software properly, so that's why you need to take the training over there. In terms of training, there is no charges. Only thing is that you have to get there, that you have to pay for your ticket, they arrange for your accommodation and everything. So it's a pretty, for academic people, it's a nice kind of system. It's a good software. Last year we had a master's student here working with me who used this software. So I did happen to take this training a couple of years back. So I do have a copy of this particular software, and that's its focuses on waste management. So it's the focus is on waste management. As some of you, if you have Googled enough about me, you know that my core area is on waste management. So that's how I'm work from waste management. I moved to this life cycle analysis area. So I do both waste management and life cycle analysis. And if you think carefully, there is a good relationship between the two as well. Because when we talk about life cycle of material, waste is a material too. Somebody's waste, it could be waste for you, but it could be material for somebody else. So it has a value for other people. So that's your cradle to gate study, gate to grave study, which is focused on waste management system. Now we will look at some of these. Let's look at this example on how you define the system boundary. And as I said, you need to be always careful in terms of having a proper definition in terms of system boundary. This particular has come from a French paper, French report. That's why you see some of this French language over here. But don't worry too much about that. I have it's a study done early in 90s comparing a McDonald's versus a conventional mom and pop restaurant. So again, some of this language is a Western language. So when we say McDonald's, everybody of us knows McDonald's. There is enough ad on TV now on McDonald's. So you know, even in India, McDonald's is a very popular place. Actually, if you go to the Western countries, if you go to US or Europe and other places, most of the people actually don't like to go to McDonald's. McDonald's is considered a poor people's place for eating in America and other places. Here we still have craze for McDonald's, and especially with the small kids because of those toys that they give. But okay, here if you look at the comparing McDonald's, study was done in early 90s, and conventional mom and pop. Mom and pop restaurant means it's a conventional family restaurant. So it's a conventional restaurant where if you remember, if you look at any of these big chain restaurants, they are this McDonald's or KFC or to the certain extent Subway. Subway is a bit different, but there are other chains out there. I don't remember right now, but these Burger King, for example. So these restaurants, they get semi-cooked food from a centralized warehouse kind of place. So they get semi-cooked food and then they just do the preparation over there. So there is no cutting of vegetables and all that happening, which happens in a conventional mom and pop restaurant. Mom and pop restaurant means a conventional family-owned restaurant where you walk in, you give an order, and then they cut the vegetables and prepare it for you sometimes, and then they give you the food if you're asking for something unique. If so, there's something that they have made for that particular day, which they list anyway as a specials for the day or like a vegetable for the day. If you buy that, that's again, but that also produces a lot of food waste over there. So if you want to compare these two, again the system boundary has to be an equivalent, because that's the critical. If you're trying to compare these two systems, a McDonald's versus a mom and pop restaurant, so both of them has a similar system boundary. So let's look at this table to try to understand what I'm trying to say over there. So for both, if you look at McDonald's as well as the conventional restaurant, in terms of the agri-food production, in terms of the production of the agricultural produce, and from there to the food, it's the same. It's the same whether you eat, say if you are eating a certain veggie burger or a chicken burger, whatever, in a McDonald's or a conventional restaurant, the stuff that needs to get to prepare that is the same. So agricultural aspect will remain the same, and the production of agricultural food processing will be more or less the same, and there will be transportation involved in both cases, in the case of McDonald's as well as in the case of conventional restaurant. Now in McDonald's, what is there? They have a centralized preparation. So they have a centralized preparation. So here they do a centralized preparation. So that means they don't do a lot of preparation in their individual store. So The preparation is done, for example, in a city like Kolkata or say Delhi or other places, they will have a centralized location depending on how many units they have on that particular city. Sometimes even the food comes, the centralized location may not be in that city, maybe in some other city. Pretty much we do have a subway at IIT Kharagpur campus over here, and subways, most of the stuff actually comes from Kolkata to this particular subway, because the centralized location where the food, all those salads and other things actually comes from Kolkata, which gets, they use it over here. So that's why they don't produce much food, they don't produce much food waste from the sense of like a preparation of food. They may produce food waste if people don't eat it, people don't take the whole sandwich and don't eat the whole sandwich and throw some away. So that food waste will be produced, but in terms of the preparation, for example, the coverings of onions or when you remove the skin of potato, those kind of waste they will not produce, and so they don't have to worry about that in Kharagpur, but they will worry about that when in Kolkata. So that's why you need to. But in case of conventional restaurant, it will be. In terms of conventional restaurant, there will be preparation being done. So they will, there is no centralized preparation. The preparation, they will have the raw vegetables there and they will prepare right there. So they will produce those kind of waste. So why we are talking about that? Because that waste will have an environmental impact. So we need to make sure that, when we calculate environmental impact, it's we are including all the aspects and not give undue advantage to to say McDonald's or to conventional restaurant. Then most of these McDonald's and these kind of stores, they have a disposable packaging. So they have a disposable packaging, so they will produce a lot of waste from that. But if you look at conventional restaurant, they use reusable dishes. So now this reusable dishes, those China dishes needs to be cleaned up. So there will be detergent, dishwasher liquid, hot water, and those water needs to be used for that. So there is those kind of aspects needs to be there. Food cooking, there will be some food cooking in McDonald's, but since it's a semi-cooked kind of things which they get, so cooking is usually, it's mostly just the deep frying stuff and or baking kind of the things they do. So that's a little bit different, but they do some food cooking. In conventional restaurant, they will do food preparation as well as cooking. So here they have food preparation as well as cooking. Now, in terms of cleaning, heating, and lighting, it's the same in both the restaurants. So that's both are there. And now it's if most of the people say if most of the people are eating within the McDonald's premises, many these kind of restaurants like McDonald's or this fast food restaurants are it's a pack and go as well. Like you don't eat sitting there, you eat and you basically take your stuff in a bag and just you walk out. So you are not you are just carrying the food, not eating it. You may be eating it in your car, and later on when you find one trash can, you dump it over there. So although it was a waste generated because of McDonald's, but it is being managed by some other sources. McDonald's is not managing it, but part of it, nearly say, even if you say 50-60% people are eating it in house, there will be some packaging waste. And in conventional restaurant, it will be mostly food waste. If people throw away some stuff, so that's some leftover food, no packaging here because that's in terms of food waste. So now if we think about the system boundary for this one, if we take the boundary as the restaurant's wall, either a conventional restaurant or a McDonald's restaurant, what is it really a fair kind of boundary, and whether we are being unfair to something or the other, that we need to think about. So boundaries should cover same reality. So they have the same function or the service provided. So now for both this McDonald's as well as the conventional restaurant, we have to again choose a function and the functional unit. Remember we talked about that earlier. So in terms of function, of course, is to have the meal. Now the functional unit, we can say meal for 10 people, meal for 5 people, meal for 1 person, something like that. So average meal for a person for a month or for a day, whatever, we can choose that. And in that case, say if you take the conventional restaurant, which has to do some cleaning of reusable dishes, has to have a food preparation along with cooking, and then we'll have food waste management. And for McDonald's, we should include the aspects of centralized preparation, the proportion of centralized preparation that is being done for this particular restaurant for serving that particular function. So that's also important. So it is to do that particular function, we need to get that aspect cover over there. So in terms of cooking, again, centralized preparation not only for preparation of say salads and other stuff, but also for cooking. There is some centralized cooking done. There is and then also we need to start to think about the packaging that is coming out from there. So we have to say we can take a function of serving the food, we can take a functional unit of say 30 hamburgers or 30 burgers or whatever is the most common food they sell, we can take that and compare between the two. So again, the boundaries must cover the same reality, same function or the same services being provided, but you need to look at, because situation may be different in two restaurants or the two systems. I should not say just the restaurant. This is just an example of two different systems where the way the function is achieved is different, because but ultimately both are serving meal. So that's but the unit processes will be different in two different stuff. So you need to be careful in terms of how to include those unit processes. So there are three rules to define the boundary. Number one is the compared system must provide the same function. So that's it should provide the same function, especially when we are when we do the comparative studies. Since most of this life cycle analysis is done comparative, when you are trying to compare product A versus product B or process A versus process B, those kind of stuff. The included process are those which contribute more than a fixed percentage. So there is a cutoff criteria which we talked about earlier. If you remember, we said that more than 0.1%. So those processes are included which has some sort of a significant contribution, just to have a limit on number of processes included, otherwise it gets too big. Of the total mass of the input to the system, so that's of the total mass that is to the input to the system, the total energy demand of the system. So we look at the total mass of the input, total energy demand. So we took a cutoff criteria for that. Of the total emissions of an environmentally relevant substances. So what are the total emissions coming out of that? So for that, in all these criteria, if the numbers are too small, we can ignore that particular unit process. Then the identical stage and process, since identical stage and process will have the same impact on both the system or both the product, we can eliminate that. Again, because they have since we are trying to compare the two, if there is a certain aspect which is common in both A as well as B, we can take that certain aspect out, because it will have the same impact. It will have the same unit of say CO2 emissions or whatever we are looking at. So identical stages and processes between the compared system can be excluded only if that does not affect their functional equivalence. And I will give you another example of that later on, which will make it more clearer. So if the function they give the equivalent function, even if we remove this particular process from both say product A and product B, but the function of that product doesn't change, so we can take it off. So again, rule 1 and 3 applies only when we are doing a comparative study, when we are comparing. But rule 2 applies even we are doing a standalone LCA. All the three rules applies in that case. So let's so in terms of, so that's if you look at what we have looked about, like in terms of unit processes, we started with the unit processes in this particular video, and then we also talked about the system boundaries. There are unit processes. The unit processes could be linked to each other. Again, we have to be really careful in terms of what unit processes to include. Which some of them which has a very minimal impact can be excluded. Unit processes which are common to two systems can be excluded. We have looked at cradle to grave, gate to grave, or cradle to gate, all the three kind of LCA scenarios. So that's kind of, and then we will continue to look at in terms of when you can, especially the point 3 on this particular slide when we just looked at, where the identical stage and process can be excluded. So we'll kind of look at that detail in the next video. So I hope you are enjoying this. Again, this is getting a little bit of theoretical right now, but it just to kind of give you a big like understanding of the different components that goes into doing an LCA exercise. So I'm trying to bring a lot of examples through like some of the projects and other things that we have done. So hopefully it will help you, and keep learning from these videos. And of course, if you have any questions, feel free to put it on the discussion board. We'll be happy to respond to any queries you have. Our goal is to make you learn this life cycle. So at the end of the course, you should be able to do a life cycle analysis of any product or system on your own. That's our ultimate goal, and let's work towards that goal. Okay, thank you.